what I'm going to do is talk about three different kinds of scientific experiment using three different kinds of technology that are claimed by some people to show that free will is an illusion, that free will doesn't exist. And I wanted to start really by talking just a little bit about my motivation for writing on this topic, because there are all kinds of things a person can write on, and this is something now I've been writing on for a few years. And I'm going to talk about three problems that all three of these experiments have in common in generating the conclusion that there's no free will. But now, motivation. So actually, I worked on theory of free will for a very long time. And I also track science of action because I'm very interested in how actions are produced. All kinds of actions, just simple actions, complicated actions. And so I knew about the neuroscientific studies that, way back in the 80s, actually, that were claimed to show that there's no free will. And I thought, oh, they don't show it, and I don't think people are going to take it seriously. But eventually, this stuff made big news, and it was online a lot, in newspapers and so on. And just to give you a feel for it, I'm going to read you from two relatively recent online articles about free will. This one, the first one, is from Science Now Daily News. It was 2008. Your mind might be made up before you know it. Researchers have found patterns of brain activity that predict people's decisions up to 10 seconds before they're aware they've made a choice. The result was hard for some to stomach because it suggested that the unconscious brain calls the shots, making free will an illusory afterthought. The experiment the author's talking about there is one that I'll talk about a bit later. It's done with fMRI. I'll explain that later. And here's another one. This also is from 2008. This was December. It's from Science News, and the article was called The Decider. Here it is. Free will is not the defining feature of humanness, modern neuroscience implies, but is rather an illusion that endures only because biochemical complexity conceals the mechanisms of decision-making. And so it was stuff like this that motivated me to, start writing a book on it, but a serious book, a book for scientists, philosophers, and grad students. And eventually I wrote the book Free that was mentioned. And that's a book I tried to reach everybody with, and I hope it will do it. And the dialogue that was mentioned is a book for undergrads explaining the scientific critique of free will. In those books, I go into scientific assaults on free will from a bunch of different angles, including social psychology and cognitive psychology and neuroscience. But I can't do all that now, so I'll just talk about the three different kinds of neuroscientific argument for no free will. Okay. So when I was writing this book, I got an email out of the blue from somebody I didn't know. And here I'm going to read it to you. And I ended up putting this in my preface after getting her permission to do so. I recently purchased a DVD by Dr. Stephen Walensky. He explains from the point of view of neuroscience that there is no such thing as free will, as we can only perceive an action after it has already occurred. Can you please help me with this? I can understand that I don't know what thought will occur next, but that has already happened is beyond comprehension. Thank you, as I am in a lot of despair. Now, it's kind of amusing and sad at the same time, and that was the sort of effect I was worried about. People would read that they don't have any free will and they'd get depressed. Now, until 2008, we didn't have any hard evidence on the effect that the news that there's no free will has on people. And then we started getting some hard evidence. So two social psychologists, Kathleen Voss and Jonathan Schooler, did a study in which the subject pool was divided into three groups. There was a group that read passages saying that nobody has free will. There was a group that read neutral passages. And there was a group that read passages saying that people do have free will. And then the next task was to take a little math quiz. And they were told, the cover story was, the program is glitchy, so that if they don't press the space bar right after the question shows up, then the answer is just going to show up on the screen, in which case they can cheat, of course, because the answer is right there. There's also a version of this in which they get $1 for every correct answer. And it turns out that the people who read the no free will passages cheat significantly more often than the other two groups. And the other two groups behave essentially the same, which, by the way, is evidence that free will is a kind of default assumption, because telling people they have free will doesn't change their behavior at all. It just keeps them the same as the control group. And then my friend Roy Baumeister, who's also at Florida State University, did a study in which he had just two groups. And one group read neutral passages, that's the control group, and the other group read no free will, statements like you're not in control, everything's in the cards, stuff like that. And the next task was to serve snacks to people who were about to walk into the room. And they were told two things about these people. They have to eat everything you put on their plate. And they've all indicated that they really hate spicy food. And the people who read the no free will passages doled out way more of the spicy salsa option than the other group did. So there, lowering confidence in free will increases what looks like aggressive behavior. And you might wonder what's going on there. Well, what might be going on is they're thinking, no free will, I guess I'm not responsible for anything I do. I've got this urge, why not go for it? You know, punish the person with the spicy salsa. So we do have evidence that the news that there's no free will increases misbehavior. Now, if the news is true, then we have to deal with it. We have to figure out what to do. But if it isn't true, then we can sort of shove it off to the side, or at least that's what I've been trying to do for a few years now. Before this multi-million-dollar grant, I had a $4.5 million grant on free will in science. And the money was given out in subgrants, and I subgranted money to people who disbelieve in free will, people who believe in it, and so on. But we did a lot of nice neuroscientific experiments and social psych experiments, and we know more now than we used to. Okay, so just a little bit of terminology. So decisions and intentions, because all of these studies are about, well, deciding to do something at a certain time or coming to have an intention at a certain time. So the way to think of deciding for our purposes is as a momentary action of forming an intention to do something. So I might decide now to snap my fingers now, to give an example, and I might decide now, while I'm talking to you, to find a way to take a break between this session and then my next one tonight at 8 o'clock. And in both cases, the deciding is a little mental action, needn't be conscious, I'm not saying it has to be conscious, of forming an intention to do something. Intentions you can think of however you normally do, because it turns out most people think of intentions in basically the same way. And then among decisions and intentions, there are proximal ones. There are decisions now to do things now, or intentions now to do things now. And there are what I call distal ones, decisions now to do things later, intentions now to do things later. And in all of these studies, it's proximal or very nearly proximal decisions and intentions that are being studied. Okay, now pretty soon, my daughter is an artist. She's actually a wonderful artist, and I have no artistic talent at all. So don't count on this to look exactly like the EEG chart I'm talking about. But in my mind, you know, it's close, but I can't really tell because I'm sort of art blind. So I'll talk about the experiment shortly, this first one. But I just want to give you some empirical claims, some claims from the literature. So now the first one I'm quoting from Benjamin Libet. Benjamin Libet is the neuroscientist who got the no free will ball rolling in neuroscience. And actually his position's a little more subtle than he's usually given credit for, and I'll talk a bit about that. But anyway, here's the quotation. The brain decides to initiate, or at least prepare to initiate, certain actions before there is any reportable subjective awareness that such a decision has taken place. So the claim is, you know, the brain's making these decisions unconsciously, and we pick up on the decisions after they've been made. The next one, because brain activity in the supplementary motor area consistently preceded the conscious decision, it has been argued that the brain had already unconsciously made a decision to move even before the subject became aware of it. And I'll talk about that. Now we get a theoretical claim that links these alleged findings to free will. If the act now process is initiated unconsciously, then conscious free will is not doing it. And then we get a claim, that was Libet again, another claim from Libet, where he generalizes from his apparent findings in the experiment I'm about to describe to all cases of deciding. And here it is. Our overall findings do suggest some fundamental characteristics of the simpler acts that may be applicable to all consciously intended acts and even to responsibility and free will. So now let me, I think I'm done with all that. Let me describe to you the original experiment that got this going. So your task as a subject is to flex your wrist whenever you want, and you're watching a very fast clock. It makes a complete revolution in roughly 2.5 seconds. So it ticks around. You're hooked up for EEG readings, so we're measuring electrical conductivity on the scalp, and also muscle motion. And when subjects are regularly reminded to be spontaneous, that is, not think at all in advance about when to flex, and you always do at least 40 trials because you need a whole bunch of data so you can do some averaging of the of the results. The EEG ramp-up starts about 550 milliseconds before the wrist muscle moves, but the average time of first reported awareness of the decision or urge or intention, different terms are used, is about 200 milliseconds before the muscle moves. This they call W time. So the idea is, after you flex your wrist, you wait for the clock to stop moving, and then the way you do it now anyway is you move a cursor to the spot on the clock where you think it was when you were first aware of your urge, decision, intention, or whatever. So the average time there is 200 milliseconds. The EEG ramp-up starts here at 550 milliseconds, a little more than half a second before the muscle burst. And so back to those quotations now, what Libet is saying is, well, look, what's going on is that the brain is deciding here, and the person doesn't become aware of the decision for another third of a second, roughly. And then we get the generalization to all decisions. So all of your decisions you make unconsciously, and then later on, after you make them a bit later, a third of a second, you become aware of them. Okay, now there's another aspect to Libet's study that I want to talk about before I get on to the next study. So Libet thought that there was a tiny window of opportunity for something like free will. He thought that free will could never initiate actions, but what it could do is veto an intention to do a thing, or veto a decision to do a thing. It could kill it, cancel it. So now I can add a little bit to my chart. So what Libet thought then is that, I should probably stand here, what Libet thought is that once you became conscious of your intention to flex now, or your decision to flex now, you had about a 100 millisecond window of opportunity to veto it. And he thought he had two different kinds of evidence for that. One kind is that after the experiment, quite a few subjects actually said, sometimes I had the urge to flex right then, but I just didn't act on it. I let it go and I waited for the next urge to come along. So there's that kind of anecdotal evidence for veto power. They felt the urge, but they didn't act on it. But another thing Libet did then was to do a veto study. He was trying to find evidence for veto power. And in the study, what the subjects were supposed to do, their instructions were these: prepare to flex when the spot hits a certain point on the clock, like the 9 o'clock point, say. So prepare to flex when the spot hits there on the clock, but don't do it. And when he did that experiment, he got an EEG ramp up starting about 1 second before the designated time, like if it was the 9 o'clock point, 1 second before that. It started ramping up there, and then remember the but don't do it part, and it started petering out 250 to 150 milliseconds before the designated time. And then what Libet said is, well, look, this is evidence of veto power, because here these subjects intended to flex when the spot on the clock hit the 9 o'clock point. and then they canceled it. Now there's a kind of flaw in that experiment that I could go on and try to explain in a technical way, but it's really easy to see if we just do our own experiment, so a free one. So we're going to do it now, and I'll ask you to cooperate. Usually I can see the audience pretty well, but the lights are a little bright, so I can't see all of you. So what I want you to do, I'm going to count 1, 2, 3, and I want you to prepare to snap your fingers like this when I get to 3, but don't do it. Okay, so you prepare to do it, but don't do it. And I'd sort of like you to pay attention to what's going on in your head as I'm counting to 3. Can you do that? Okay, so let's try it. So you remember now, so you prepare to do it, but you don't do it. Okay. 1, 2, 3. Okay, good. Now, question, how many of you intended to snap your fingers when I got to 3? Answer, nobody. And how do you know that? Well, you know it sort of introspectively. You can also infer it maybe from your behavior. What did you intend to do? Well, you intended to prepare to flex when I got to 3, snap when I got to 3, but not to do it. Okay, so what Libet is measuring here isn't the power to veto an intention you had to snap your fingers when I said 3, or an intention his subjects had to raise a wrist when it got to the 9 o'clock point. What he's measuring is something else. And then what you might wonder is, what is he measuring? You know, what's going on back then? Well, it could be preparation, or it could be thinking about doing a thing at a certain time, and I'll come back to that. And actually, you can do other kinds of studies where people are just thinking about doing a thing, you know they're not going to do it, where they're preparing it, or where they're watching somebody else do it, and you get similar charts. The 2008 study that was mentioned in that first quotation from Science News that I read you, this was done with fMRI. So what you're reading are changes in blood flow in the brain. It's a slower kind of process than the EEG because it takes blood oxygen about 3 to 4 seconds or so to get to where it was most being used. In this task, so while doing the fMRI, subjects had the task of pressing either this button with this finger or that button with that finger, and it was up to them what to do. And the scientists in the paper claimed that they could predict with high accuracy, the high accuracy part is a quotation, 7 to 10 seconds in advance of a button press, which button the person would press next. And that's I'm going to read that passage to you again. So this is the first one I read. Your mind might be made up before you know it. Researchers have found patterns of brain activity that predict people's decisions up to 10 seconds before they're aware they've made a choice. So the thought is, look, the brain has already made that choice, 7 to 10 seconds in advance, and you don't become aware of it for quite a long time. The result was hard to stomach because it suggested that the unconscious brain calls the shots. Now here's the connection to free will, making free will an illusory afterthought. Okay, so we'll see a problem with that experiment in a minute. Here's a study done by Itzhak Fried and co-authors, a really interesting study. So sometimes when epilepsy patients can't be well treated with drugs, they opt for surgery, and part of the skull is removed. And then if they consent, they can be involved in science experiments where an electrode grid is placed directly on the brain, or electrodes are inserted directly into the brain, and then they can do various tasks. With my Big Questions in Free Will grant, we funded one study like this. It wasn't the Fried study. It was a very interesting study. And by the way, there's on PBS a series called Closer to Truth, and there's an 8-episode series on Closer to Truth, and in one of the episodes, you can see our EEG study, our depth electrode study. It's really cool. Okay, so now the task here is just to click a key on a keyboard whenever you want. That's the task. And they were taking readings directly from the brain, and 800 milliseconds in advance of a key press, they could predict within a window of about 300 milliseconds, so it's not pinpointing it, but they could predict with 80% accuracy when the person would press the key. And what they were also measuring was when the person would say the person became aware of the intention, and that was about 100 milliseconds before muscle motion began and 200 milliseconds before the key made contact with the switch under it. Okay, that's 80% accuracy. That's pretty good. All right, so I said I would describe 3 different experiments, using 3 different sets of technology, and then I would try to explain why we can't really justify the conclusion that there's no free will based on these findings, and I'm going to get to that part now. Always at the end when I give a talk like this, somebody will ask me, what does free will mean anyway? And a nice thing about this talk is we don't have to get so much into the semantics of it, because we can see that there are problems just getting to the claim that decisions are made unconsciously in these experiments. And that's the key claim. That's how they get to the conclusion that there's no free will. Well, look, you're not making your decisions consciously, and you need to make them consciously in order to be acting freely. Okay, so now there are 3 different problems I'm going to talk about, and each one is a problem for each of the 3 experiments. The first one is, so back to Libet, what happens at minus 550 milliseconds in Libet's study? That's where the EEG ramp-up starts, and so you should be wondering, well, is that where the decision is made? That's Libet's claim, and it's an important claim to get his argument to go. Well, one question you'd want to ask in that connection then is, how long does it take a decision to do something now, or an intention to do something now, to generate muscle motion? Does it take 550 milliseconds? Might it take less time, for example? Now, we do have already, and we've had for years, indirect evidence about this. So you can do reaction time studies in which a subject knows what he or she is supposed to do when the subject gets a go signal. So it might be when you hear a beep, then what we want you to do as quickly as possible is flex your wrist. Now, to get data that would be even more useful in answering our question about Libet, what you'd want is a reaction time experiment where subjects are watching a clock, in fact, a Libet clock, a fast clock like this, because watching the clock is going to divide attention and it's going to slow down reaction time. And now there is a study like this. It was done by Patrick Haggard and Elena Magno. It was published in 1999, as I recall. And the mean time between the sounding of the go signal and the beginning of muscle motion, it's called a muscle burst, was 231 milliseconds. So the time between intention and muscle motion is going to be less than 231 milliseconds because it takes a little time to detect the beep. And then if the way it works is you detect the beep, that generates the intention that then generates the muscle motion, well, the intention is closer to the muscle motion than 231 milliseconds. That's one study. Here's another one. This is a recent one. It's on my handout. It was done by Trevina and Miller, 2010. It's a study I had suggested back in my 2009 book, Effective Intentions. And the idea is this. So have a study where people have 2 options. They can press this button or that button. And set it up so that you tell them, don't make your decision until you hear the beep. And the beep, instead of being a specific go signal, like press that button or press that button, is to be treated as a decide signal. So we say, when you hear the beep, decide which button to press and then go ahead and press it right away. And what happened in that study is that there was no difference in pre-tone EEG. So the EEG before the decide signal was the same no matter whether the person then went left or then went right, which is evidence that no decision had been made prior to the decide signal. And the mean time between decide signal sounding and muscle motion beginning was 150 milliseconds. So if the decision is made there, it's really close to the beginning of muscle motion. It's in here somewhere, around 200 milliseconds, rather than way back here. But then if the decisions are being made around there, they're being made during W time. at the time at which the person is conscious of making them. Okay? All right. So now back to the Soon et al. Study, the study done with fMRI, where they said that with high accuracy they could predict 7 to 10 seconds in advance which button the person would press next. Well, the high accuracy was 60%. Now that's significant. That's 10 points above chance, but it really is only 60%. And just to illustrate what that amounts to, notice this. If I had a fair coin and you had 2 buttons you could press and you're going to press one or the other next time, I could predict with 50% accuracy just by flipping my coin, right, which one you're going to press next. And they're doing 10 points better than that. So what are they detecting? I mean, they are detecting something. They're 10 points better than chance. They're not just guessing. What are they detecting? My hunch is they're detecting a certain kind of bias. So in this study, what you're supposed to do is press this button next or that button next. You do it a whole bunch of times. You're not supposed to fall into any patterns, so you have to keep track in a rough and ready kind of way. And I think what's going on is that as you go through the task, you will build up in yourself for the next press a certain bias or inclination that you're not even aware of to go left next time or right. And maybe it's one that just increases the probability that you'll go that way, but not by much. And that's why we get the 60% accuracy rate. But notice that if it's that kind of thing that's going on, it's no problem at all for free will, because it's not as though your brain has definitely decided back then. All it's done is given you a little nudge in a certain direction. A nudge that you could go against, apparently. Okay. So, and then the Fried study with depth electrodes. Well, there the response, the claim is going to be similar. Their accuracy rating is way higher. It's 80%, which is impressive. But the 80% figure doesn't indicate that a decision has already been made at, let's say, minus 800 milliseconds. And it's utterly consistent with the hypothesis that what's going on there is you're getting closer to making a decision to press now, but you're not all the way there yet. You're getting closer in a way that doesn't ensure that you'll go all the way and make your decision at that point in time. And I think that's quite likely. Now, I've made all these points before, and sometimes people will respond, well, even if you're right, let's go back to Libet. That's sort of the simplest one to see because we have our picture. Even if you're right that the decision isn't made here, and even if it's true that the decision is made around here, around the time you say you're conscious of making it, they say, well, the point of no return has been hit back here. And the point of no return is a point such that once you get to it, you can't stop the process in any natural way. Okay? So they could claim that. And so they could say, well, this consciousness of a decision isn't really doing any work because everything's already been settled back then, even if a decision hasn't been made back then. All right. Now, see, this is where it'd be good for you to have the handout because there's a quotation on it from Libet's method. It's about Libet's method in doing the study. I'm going to read it to you. I'm going to read it slowly because it's crucial. In the absence of the muscle's electrical signal when being activated, there was no trigger to initiate the computer's recording of any preceding brain activity. Now, here's the significance of that. If you want to know whether the point of no return is hit back here, what you'd want to be able to do is inspect brain activity, starting from there and let's say halfway to 0 or so, and see whether you can ever find any cases where you get a signal that looks like this, right, this part of the signal, but you get no muscle motion at 0. And what he's saying in that passage that I quoted to you is that he's using the muscle motion itself as the signal to the computer to make a record of the preceding second or so of brain activity. So if you're using the muscle motion to signal the computer to make a record of that brain activity, then you don't have any record of any brain activity that happens when a little bit later there's no muscle motion. right? So he hasn't been able to look for the point of no return. And people have worked on ways of trying to solve that problem, but here's just one more thing about that. This will make it really clear, I hope. So when you do the EEG stuff, you do something called back averaging. And what happens is you need then something to signal the computer to, let's say, save that preceding second of brain activity so you can match it with others and come out with a result. And his signal in the main study was the muscle motion. Now in that veto study that I talked about, so there was a signal, and it wasn't muscle motion because there was no muscle motion, right? That was like the snapping the finger thing where you don't actually do it. The signal was the clock hitting the 9 o'clock point. Okay, so you always need a signal when you're doing EEG. Okay, so we don't have good evidence that the point of no return is hit here. In fact, we don't have any evidence because of the way the experiment was conducted. And Libet himself wasn't claiming that the point of no return was hit there because he thought we had veto power. So he wasn't looking for a point of no return. And we don't have good evidence that the point of no return is hit 7 to 10 seconds in advance in the fMRI study or 0.8 of a second in advance in the depth electrode study. The first problem was then, just to repeat, we don't have good evidence that decisions are made early at half a second before the muscle burst, 7 to 10 seconds, 800 milliseconds. We don't have good evidence for that. We don't have good evidence for the claim that the muscle burst, that the point of no return is hit that early. And now we're going to go on to the third problem. Now, here's the third one. This is sort of a counterfactual or hypothetical issue. I put it this way. So even if it were true that all proximal decisions are made unconsciously in these experiments, would we be entitled to generalize to all proximal decisions, or all decisions, proximal or otherwise? And remember, the proximal decisions are decisions you make now to do a thing now. So what you could do then, just to simplify it, is suppose, for the sake of argument, that these experiments really had shown that in them all the decisions to do things right now were made unconsciously. Just suppose it. And remember the generalization claim I read to you at the beginning, because Libet wants to get from his results to all cases of deciding. Now here I think it helps for me to describe my own experience as a subject in a Libet-style experiment. So years ago, it was 2005, I gave a lecture on free will and neuroscience at the National Institutes of Health to a very smart group of neuroscientists who work on muscle motion and action production. And the deal was, I give my lecture, we do the questions and answer, then I'm a subject in their experiment, and then after I do the experiment, they take me out to dinner. Okay, so that was the plan. Sounded like a good plan. And I wanted to see what it felt like to be a subject in that experiment. And my plan was to be a very naive subject. So I went in there without any preconceived plan. I thought what I would do is I'd wait for urges to flex now to pop up in consciousness. And then as soon as they did, I thought I'd flex. And I'd be watching the clock in the meantime so that after I flexed, I could move the cursor and say where the spot was on it when I first became aware of my urge. And what I noticed is that nothing was happening. That is, nothing was popping up in my head. No urges to do it, no intentions to do it, no decisions. Just some questions. And my questions were, how do people do this? How do they do the task? And how am I going to do it? What's my plan going to be? Because frankly, by that time, I was getting a bit hungry, and I knew I had to do it before I could go out to dinner. And I also didn't want to look like an uncooperative jerk. So my plan was to say now to myself silently and treat that as a decision marker. You could say treat it as a go signal, and then flex as soon as I could in response to the silent now saying. Now, why was it so hard for me to have these urges or whatever? It's because what I was doing was arbitrarily picking a moment at which to begin flexing. It's like when you go to the supermarket and you have your shopping list, and maybe if you're like, I like peanuts a lot, so you have a 16-ounce jar of Planters peanuts on your shopping list, and you get to the peanut display and you just pick one. You don't think about which one is better than which because you know they're all the same, right? So that's what this is like. It's arbitrary picking. So Buridan's ass. I want to work Buridan's ass in here because last time with the handout, when the audience had the handout, I forgot Buridan's ass and I made a mental note never to forget it again. And now I knew it was coming up and I'm not going to forget it. Okay, so Buridan's ass. It's a famous old parable. There's a donkey that is hyper-rational. So it will never do a thing unless it has a better reason to do it than anything else. Okay, that's Buridan's ass. And one day it's walking around and it's hungry and it finds itself equidistant between two equivalent bales of hay. They're just as attractive, they're just as large, and so on. And they're each just as far from the donkey as the other one. So it's hyper-rational, and so what it does is it starves to death because it doesn't have a better reason to go this way than that way. But we're not built like that, fortunately, because, you know, it'd be hard to survive. What we do is we make random choices. And there's no need for any conscious processing to make those random choices. You just pick. Okay. Now, remember that in Libet's study, and all these studies, subjects are told to be spontaneous. So they're not supposed to think in advance about when to flex or which button to click or anything of the sort. So how much like a lot of ordinary real decisions that we make are these decisions that are really just arbitrary choices? And so just think about some tough decision you had to make. For different age groups, I give different examples, but I can't see too well because the lights are bright. So let's do divorce. Let's do that one. It looks like some of us are old enough for that. And so you think about it day after day. Geez, you know, should I do it? What about the kids? Oh, now they're maybe old enough where it could be okay. And, you know, there's all this conscious processing. And then eventually, in the end, you make a decision. Or you might have a nice job, but you get a really nice job offer. And then you think, geez, I could leave all my friends here and take this other offer. And you might even, I mean, if you're like me, and you get to a case like that, you make a list of pros and cons, and you cross off things that are equivalent. And so this is nothing like arbitrary picking. But if that's right, then you're not in a position to generalize from alleged findings about arbitrary decisions to all decisions. Also, where conscious processing is preceding the decision, the processing itself will raise the probability that the decision is conscious. So the more conscious thought goes into a decision, the more likely that the decision will be conscious. Whereas in these experiments, consciousness is shoved off to the side. I made a little note to say something about the free will literature, and I think I should. So there's a view called restrictivism in the philosophical free will literature. And according to this view, you exercise free will only in cases in which you are torn between competing options. Often the options might be what you think you ought morally to do, what your moral duty is, and what you're tempted to do. But sometimes the options could be long-term self-interest and sort of short-term temptation. And the restrictivists, these are theorists now, they're philosophers, say that's the only place where free will can be at work. Now, if that's right, the arbitrary picking studies are not about free will at all, because they're not about being torn between competing options, they're about something else, random picking. But even if the restrictivists are wrong, we should see that there is a huge difference between randomly deciding and then deciding after painstaking conscious reasoning. And given that there is a huge difference, we're in no position to generalize from what we find about random picking to all these other cases of decision. And if that's right, then all those decisions, the free will with respect to them isn't challenged, isn't threatened.